Hello guys, welcome to DotNetCrunch, and this is part 9 of Typescript series, and today's topic is generics in TypeScript. So in case you missed our previous videos, I'll provide a link in I button wherein you can watch the entire playlist for TypeScript. With that, let's get started. So we have open Visual Studio and I have created generics.ts file, and I have just listed down what will be the agenda of this video. So we're gonna look at what is generics, why we need generics, and we'll be explaining the concepts with the help of some code examples, and then we will see how we can use generics in classes and interfaces. Okay, so with that, let's get started. So generics, what is generics? Basically, generics in TypeScript is nothing different than generics in any other programming languages like C# or Java. So you can create class or an interface or a function that works with different types without specifying the type upfront. So if that is confusing, if that definition sounds confusing to you, need not to worry, we'll see that all that in action. The most basic generic type in TypeScript, which is array. So let's say we have an array of type string, and so whatever we specify in this angle bracket is considered as a generic type, is considered as a generics. Okay, so instead of having this string over here, we can have a placeholder which will act as a generic data type. So t is a standard, like it's a practice which is being followed. You can have any name over here, doesn't matter. Okay, it's just a placeholder, so we'll go by the convention. So t means like you can pass in any data type over here, and it will be decided at the runtime what data type you pass. So that's basically generics. Okay, now the question arises, why we need generics? Okay, so for that, in order to demonstrate why we need generics, we'll first write a code. We'll code a function. So let us write a function to get the last element from a given array. So we will have a input array of type number. So let me define that array variable, and let's give it arr, and then we'll have an array of type number. Okay, so this is our input. We'll code the logic for this. So we minus, to get the last element, we minus the array length by 1. Okay, so this will give me the last element. So let's consume this function. Let's call this function. So let's declare a variable to hold the value element equal to get last element, and let's pass on the numeric array. So let me pass 10, 20, 30, only 3 numbers as of now, and this should give us, so when you hover over the element, it is of type number. So now suppose our input is a string array, and we want to get the last string element. We cannot reuse this function because it will give error, because that we have strictly specified the type as number. It only accepts the number. So we can solve this using any keyword which is available in the TypeScript, but the problem it creates is like we are not able to specify the type, right? So it's always any. So in order to solve this, we can use the generics concept. So we'll specify a t, and as a type t, you can use anything instead of t. So when you hover over the elements, it gives you like number and string respectively for both these cases, and our function now works in a generic way. So that answers why generics. Okay, so now we have explained what is generics and why we need generics. Hope it is clear, and we have also seen this with the help of a code example. Now let's focus on interfaces and classes, declaring them as a generic type. So let me code in interface, a normal interface. Let's say we have an interface called book. Okay, there's a type over here, interface book, and this will have some parameters, the ID of a book, which is of type number, and then name of the book, which will be of type string. And let's assume we have one other field which is of type data, and we are not sure of the type. Let's assume it's a string, but we are not sure. It can be a string, it can be a integer, a number. So what we do in that case, suppose this interface, we have this interface book, and we want to implement this interface using generics in a generic way. So what we can do is we can have this T symbol over here, and for this data so we can have a T. So suppose now if we create a type of this interface book, which is equals to book of number. So in this case, the book object, which the type which we have created, so which will pass as a number, so this data will also be of type number. Sorry for the typo. And if we want to work with some other type, let's say string, so what we can do is we can pass on here as string. So in this way we are not limiting our interface over here with a specific data type. We are making it more generic in order to work with any type of data type passed at runtime while creating an object, or while calling that interface, working with that interface. Okay, that is the concept of generics. Okay, so similarly we can have a generic class. So let me define one class of type let's define a list which is of generic. Okay, so in this class we will have one private data member which will hold our data. I'm just giving a data name because it's just coming to my mind right now. And this data will be an array, and this array will be a type of type generic. So this is how we declare a generic array. Okay, so what this states is like this is a class list, and whenever we invoke an object and initialize this, it will be of type generic. So it can be a number integer or a string integer. Okay, so here I'll specify the constructor for this class, and we'll have a spread operator over here, elements, and which will be of type generic array. Okay, so here we'll say this dot data equals to elements. Okay, so this is our generic class, and this is the constructor. You can implement various other methods over here in order to add data, remove data, but I'm not doing it for here. I was just wanted to show you the example of generic class. So in case, like, whenever you will invoke the object, let d equal to new class of type. So this is the generic type. We can specify number, and I'll pass on number array, so 1 2 3, let's say. So this is perfectly fine. It will go ahead over here and it will it will add data, add all the numeric data to that number. Okay, now we have let a equals to new list of string, and we pass on here string. Okay, A, B and C. So this also works fine because we have not limited our class to accept any specific type. Suppose we remove this generic functionality, it will break. Okay, so this is our generic class. It works for any data type. So that's all, guys, for this video. Hope the generic concepts in TypeScript are clear. If you have any concerns, please comment below the video, and don't forget to like this video and share it with your friends, and also consider subscribing this channel. Thank you.